The boundary descriptions represent the smooth topological states of the information on the surface of the mirrors. These surfaces represent the manifold, as I've discussed in former videos. When information, which we'll call light or energy, quantum information, is projected to these surfaces, the information, represented as light rings, spreads smoothly and uniformly across the screen. So these surfaces and the information existing upon them form the relationship between a reflective medium and the volume of information implanted on the reflective medium, or the topology of the medium itself. And I'm going to actually refer to this dark matter medium or vector, and we're equating that to a surface of a mirror, or the mirror itself can represent the dark matter candidate. And I'll express this more fully with other videos. So the information dwelling on the surface represents the topological state of the information of a black hole. The information on the surface of the black hole boundary condition, that is the mirror, represents, or the information on the mirror, represents a finite volume of reflected holographic information. In that sense, the dark matter vector, medium, mirror, has information implanted on it. The mirror is not technically the surface of the black hole. The surface of the black hole represents the information of the black hole, that light ring that exists on the end field. So this shows a distinction between the actual body of information comprising the black hole as distinguished from the whole of the area of the vector itself, the end field. So the information on the surface of the black hole boundary condition represents a finite volume of information. That is, we have a finite one-dimensional circle on the surface. It's finite, it's set, and it expands and contracts relative to what is happening with the real object going toward or away from it. So this finite volume of information on the surface is then expressed infinitely in opposite direction via recursion. So we have a finite volume of information on the surface and then an infinite of finite timeline. So it's the virtual matrices of the interiors of the black holes formed when two reflective vectors, M fields, are relative to each other. In these virtual matrices is where the perturbative vibratory conditions exist. So these matrices represent the interior of the black holes. And due to these matrices existing of necessity, we can mathematically state that in order for the matrix to exist, or an interior of any black hole, that black hole has to be, mathematically certainty, has to be relative to another black hole. If we go to an isolated black hole, then all we'll have is a volume of information on the surface, infinite volume, that's not being infinitely extended recursively. But when these matrices come into relativity to each other, then the matrices emerge. So again, no black hole can have an interior unless it's facing another black hole, or another mirror with a body of information projected to it. So the relationship between the surfaces of two black holes embodies the principles of special relativity and represents that the two topological manifolds, or states of flow of information, are coupled and can therefore interact with each other. As well, this coupling constant is further extended due to the relationship of recursion. Due to the entanglement of the surfaces results in recursion, establishes that there's two recursive errors of time, whereby the information within the interiors of the black holes are linked the same as the information on the surface are linked, and can interact down the timeline on this end, down the timeline on this end, and not only interact, but interact in a constant way in the sense of opposites. In other words, whatever happens here, the opposite is happening here, counterbalancing equilibrium. So the surface state of information is smooth. The recursive states are vibratory, entropic. The virtual recursive conditions, right-left matrices as entangled and interacting, represent the harmonic oscillator. or the harmonic oscillators. Remember, the harmonic oscillator will not exist unless two planes are relative to each other. If you isolate the mirrors from each other, the harmonic oscillator, as being described recursive, would not exist. There would just be the smooth representation on the surface. But once the entanglement of two black holes occurs, then we have, in essence, the whole harmonic oscillator of the string, but it's represented as a harmonic oscillator here to the right, a harmonic oscillator to the left, forming all of the oscillations that's occurring down the infinite string. So it's important to note, let me check my time real quick. So it's important to note that the recursive matrices cannot form unless there is a relationship of reflection established at the surfaces. This prime relationship, or this prime entanglement, as first emergent and expressed due to the relativity of surfaces, is describing a duality between the manifolds. Duality as it involves information. So the smooth to perturbative transition, that is the smooth flow on the surface to the recursive perturbative aspects of the system, this transition of information from a real volume of information existing on the boundary condition, smooth, to the recursive space-time continuums, that relationship is really what reconciles the Navier-Stokes existence and smoothness problem. And I'll actually have a series of probably 10 or 15 videos explicitly speaking on the Navier-Stokes later on. So this paradox will be elaborated upon, and utilizing the principles and utilizing this really, really powerful model of mirror-to-mirror, then we will remove that paradox from the intellectual, mathematical, and scientific landscape. So there's a strong interaction of surfaces when they are closer together than if they are farther apart, and thus weakly interacting. In other words, the closer two mirrors to get together as reflecting in a real object or a light source, the stronger the interaction will be between the surfaces, as well the stronger the interaction, opposite interactions of one side of the matrix relative to the other. The farther you move those mirrors apart, then the force that's exerted between the open side of the string on the surfaces becomes weaker and weaker. So again, let's refer to an analogy here. If two mirrors are relative to each other and is reflecting a real energy point existing between them, the closer the planes come together, the more intense their interiors will become. The farther these mirrors go apart, the less intense the energy manifested in the interiors will be. However, these dual harmonic oscillations, or oscillators, right, left, arrows of time, occurring in the matrices versus on the surface, spread across, will always be exactly opposite proportional to each other if the real object moves toward one manifold and away from the other. We've discussed that again in other former videos. So these differences expressed within the interiors, that is the equilibrium or the cancelling out of each other, mimic the differences between the surface states. So what this real object does between these mirrors determines what happens within the matrices, and as well determines how either contracted or expanded one side will be relative to the contraction or expansion of the information on the other mirror. And I'll continue this analogy in the next video.